All right, 8.5 polar coordinates continued. So far, about the only thing we talked about is graphing polar coordinates and rectangular coordinates, kind of how to go back and forth. So we've got our rectangular, and we have our polar. Polar coordinates is another way of graphing things, not just x comma y. Polar is r comma theta. Do you remember what r is? Good. R is the distance from the pole, and theta is the angle it makes with the positive x-axis. It's actually the polar axis in polar coordinate system. All right, so if you have a polar ordered pair of 3 comma pi, tell me what the rectangular coordinates would be for 3 comma pi and polar. See if you can do that. All right, so 3 represents the distance, pi is the angle, pi is 180 degrees. Again, if you don't remember how to convert radians to degrees, you multiply by 180 over pi. So we get 180 degrees, so it's right over here, and the distance is 3, so that would be right there. That is 3 comma pi. Make sense? All right. How about, let's try -2 comma pi over 2. Remember, if it's a negative, it goes the opposite direction. All right, so start with my angle. Pi over 2 is 90 degrees, so it's right up here. It's -2. So this would be +2 comma pi over 2, but since it's negative, it goes through the pole in the opposite direction. Raise your hand if you got that, -2 comma pi over 2. Good, pretty much everybody. All right, so let's see if we can go from rectangular to, I suppose I should write my answer. The rectangular of the first one would be -3 comma 0, and this one would be 0, -2. All right, so what if we had 2 comma 2 for rectangular? You can plot that point, and now see if you can figure out what the polar coordinates would be of 2 comma 2. I'm going to pause it this time here. All right, so 2, 2 is right up here. We need to know 2 things: how far that is and what the angle is. So I'll just make a little sketch here. Over 2, up 2. How do I find out how? If this is 2 and this is 2, does that mean this is 2?
No, it's 4. Remember, the square root of 8.
Square root of 8? How'd you get that?
2 squared plus 2 squared divided by the square root.
Good, very good. So the Pythagorean theorem will give us square root of 8. Very good. And that'll always work. So our r can be square root of 8. Square root of 8 actually simplifies to be 2 square root of 2. And if you think back to, so square root of 8 or 2 square root of 2, if you think back to special right triangles, if this is 2 and this is 2, this is a 45, 45, 90, you may recall, well, let me give you another example. If this is 5 and this is 5, what's the hypotenuse? Do we remember? 5 square root of 2. So if this is 2, this is 2, this is 2 square root of 2. So we didn't do, we talked about that at one point, but ultimately we used 2 different triangles. From there on out, we did the 1, 2, square root of 3, and then we did the 1, 1, square root of 2. So those were more important, but generally speaking, if it's a 45, 45, 90, you can just take one side and multiply by the square root of 2, and that'll give you the hypotenuse. All right, so I've already said that that's 45 degrees. We want it in radians, so it'd be our distance, which is 2 square root of 2, comma, our angle in radians. What's 45 degrees in radians? Pi over 4, very good. All right, last one of these type. Why don't you try -1, comma, square root of 3. That's your rectangular. See if you can figure out what the polar would be. All right, so -1, comma, square root of 3, I'll make a little sketch. So it's right up there. We went left 1, up square root of 3. If that's the case, what is my hypotenuse? It is 2. We remember that one. 1, 2, square root of 3. Okay, so we have our r. Is it positive or negative? Positive. Okay, so it is 2, comma. Now we need to know the angle. We need to know this angle right here. Well, this one's 60, right? It's across from 30, so that is 120, which is 2 pi over 3. Very good. Okay, 2 comma 2 pi over 3 would work. Now, what if I wanted to find the same, using the same rectangular, it corresponds with this one. Let's do another one that has a -2 on it. If it's -2, that means it has to go through the pole here. So we need to have this as our angle. So it's 300 degrees, or 5 pi over 3. So -2, comma, 5 pi over 3. If you think about it, 5 pi over 3 is right here. -2 goes right here. So it's the same rectangular with two different polar coordinates. All right, questions on that? So how are they all related? So we'll start with just a triangle right here. I will call this X, I will call that Y, and I will call this R. I don't think the triangle's in your notes, but I'll explain that you could say that x squared plus y squared is definitely equal to what? R squared. That's the thing. That's how x and y are related. We know that x squared plus y squared is equal to r squared. We could also say that the sine of theta is equal to what is it? Y over r. Opposite over hypotenuse. Very good. So y over r. So if I wanted to, I could say y is equal to r sine theta. That's another way these are related. Y is equal to r sine theta. We could do the same thing with cosine. We know that the cosine of theta is equal to adjacent over hypotenuse. So x is equal to r cosine theta. X is equal to r cosine theta. And the last formula that relates the rectangular and polar coordinate systems, you could say that the tangent of theta is equal to opposite over adjacent. So if you ever have a tangent theta, you could just call that y over x. So y over x is equal to the tangent of theta. These are your four formulas that you can use to go back and forth. So, as an example, what if you have x squared plus y squared equals 16? And that's find a polar equation corresponding with the rectangular one. So if I have x squared plus y squared equals 16, I need to get rid of my x's and y's. I can only have r's and thetas. So how do I change x squared plus y squared equals 16? There, now it's on the screen. What can I replace? What can you substitute in? What do you know is true here? We want to get rid of the x's and y's.
Well, you could do the R sine cos.
In for x, you could put in an r cosine theta. You can put in for y an r sine theta. And that will work. It's going to be a little bit more work than the easiest thing I'm looking at. Does anybody see an easier way of doing it? What's x squared plus y squared equal to? R squared. That's the easiest thing to do. Just say, oh, look at it. That's an r squared right there. So I have r squared equals 16. And then you could just square root, so r equals 4. Now it's not plus or minus because 1, 2, 3, 4. So this right here are all points that have r, or a distance, equal to 4. Well, that sounds like a circle to me. All points equidistant from a point where that distance is 4 is a circle with a radius of 4. So this has an r of 4. Now if it was negative 4, all of these negative 4s actually just correspond with positive 4s also. So you only have to write r equals 4. Okay? So what's easier, to have a circle in rectangular or polar? What's a more simplified equation? I think we'd all agree that r equals 4 is the simpler. So that's one example of where polar coordinates is better than rectangular coordinates when you're dealing with circles. So you can just write r equals 4. All right, let's do another example. We'll do y equals 3. See if you can give me a polar equation when y equals 3. All right, so we know that y is r sine theta. So I can simply make my y r sine theta equals 3. In our polar equations, generally, we solve for r. So it'd be 3 over sine theta. Or you could say r equals 3 cosecant theta. Now, comparing y equals 3 and r equals 3 cosecant theta, I think we'd agree that the rectangular version for pretty much in a lot of lines, most lines would be easier with rectangle. We're familiar with y equals mx plus b. Let's not mess it up with our polar equations. All right, how about r sine theta equals r cosine theta plus 1. All right, so I'm going to give you a polar. I want you to find rectangular. So we can't have any r's, we can't have any thetas, we only want x's and y's now. All right, so if you see it right away, it's not too bad. What can we do? Anybody? That's y. Good. So we can just say, hey, that's y. And our cosine theta is x. We get y equals x plus 1. Okay, so it's literally just the line, the slope of 1 going through the point. That if we wanted to, we're not going to do that. One last example, and then we've got a little bit of calculator work to do. How about 2 sine theta equals cosine theta? See if you can see if you can change that to rectangular. Couple ways of doing it that I see. Well, one in particular. It may not be very intuitive. I want you to think about it, and then I'll show you. All right, so we don't have any, we could actually use an R or two because we don't really have anything that corresponds with sine theta and cosine theta. What I would recommend is to R sine theta, and we have an R cosine theta, which is helpful. Because we know R sine theta is y, and R cosine theta is x. So that's the trick. Sometimes you're going to square both sides by both sides by R. You just kind of figure out what will help you get to where you need to go. So if I divide it by 2, y equals 1/2 x. So it's just the line. This right here is y equals 1/2 x. Yeah, I'll just leave that alone. I was going to talk about tangent, things like that, but we'll be done. Why don't you grab a calculator. We're going to look at another type of question you'll see. So remember, we're going to go to mode, and we want to be in polar mode, which I am. And let's have a look at r equals 6 sine 3 theta. We'll start with that. And go ahead and graph it, have a look at it, and then I'll talk about what the question would be. Help each other out if you're not getting, it looks like most people are making good progress. Marcy, you're not drawing pizzas again, are you?
No.
Well, I'll take a beef taco with some Olays. All right, so if I graph this, everyone's got a little propeller thing. Okay, so here's the question. How big of an interval is required for the curve to be drawn completely? Like, what's the minimum amount of theta we need to draw that? So if I hit trace right here, it starts at 0. It's drawing the first petal, the second petal, the third petal. Looks like I finished at, oops, went a little too far. Well, maybe I'm not finished. If you go a little bit further, you see that it's retracing it again. So there are only 3 petals. It's not like it's going to add 3 more petals. Okay, so how far did we go? Well, it looks like, I guess I went around twice. So I think it says theta equals 2 pi, but I only needed to go around once. So here's what I'm going to do. I'm going to go to window, and I'm going to go to just pi this time. Second pi. So I'm starting at 0, and I'm going to pi, and let's see if that is enough to draw the entire propeller. So is it enough? Is the whole thing drawn? Yeah. So if I change it to pi over 2, we did not get an entire propeller. And if I went back to where I started and made it 2 pi, I don't get any more than I had when it was at pi. All it did was retrace it a second time. Okay, so our answer, our interval would be from 0 to pi here. That's how long we need to go in order for it to be completely drawn. So I'll give you another one to try. Let's change it to projector here. There it is. Let's go. Let's just try 4 pi right here. So figure out the minimum interval required to draw the entire curve. Whoa, that was kind of cool. What are we thinking? Crimson, what did you get? Or don't know?
I just got my calculator to work.
Had some calculator issues. What do you think?
Mine's just making circles.
It's making circles.
Yeah.
Okay, well, it can do better than that. Will you bring it here? Anybody get an answer? Huh? You did 4, 40, not 4 theta. The theta is right here.
Oh, okay, that makes sense.
Yeah. Okay, so it's clearly not done at pi. Did anyone figure out how far you have to go? 2 pi? All right. I think that's what I got as I was tinkering around with it. Oops. So go to window. I got 2 pi. And it did complete that. So once you get into calculus, we can analytically figure out how far it's going to go. But for right now, using a calculator, I think that's sufficient. Okay, do you see that 2 pi was enough? And you could put 8 pi and it would look the same, but we don't need 8 pi. We need a minimum of 2 pi. What if, so if it was this one, I've got a 4-pedal propeller. You should try, here, I'll show you something. If my theta step is at 0.1, I'm going to change it to 1. That means it's going up 1 radian every time it's making a point. So see what happens here. So it's jumping from 1 to the next to the next. If I make my theta max to like 100, watch what happens. It just keeps bouncing. In fact, if I made it to 1,000 or 500, you ever heard, anybody have a Roomba? Do you know what a Roomba is? What is it?
Circle vacuum.
Yeah, it's just a vacuum that all it does is keep bouncing around and looking, and eventually it's going to vacuum every single spot. We just Roombaed, what is that thing? I want to do more. Right now, those watching the YouTube have already stopped and gone on. We got ourselves a boomerang. Okay, maybe I could.